Hello, today we are going to start our new chapter, Binomial Theorem. First, instead of MCQs, we will learn some important terms, definitions, formulas, and shortcut methods. First of all, what is meant by binomial? Binomial means two terms. How can you see there are two terms? Always you can see that two terms will be separated by either plus or minus. For example, x and y are two terms separated by plus. So it is a binomial expression. X and 1 by y square are separated by minus. This is another binomial expression. A and x square are separated by minus. So this is an example for binomial expression. 2a minus 5 is another example for binomial expression. So all these you can call as binomial expressions. Similarly, you have trinomial. Trinomial means there will be three terms separated by plus or minus. Let me erase this. So if three terms are separated by plus or minus, you can call it as trinomial. In the same way, there are multinomials. Multinomials, there will be many terms separated by plus or minus. But in this chapter, we will be learning only binomial, at the most trinomial. So suppose I will take, for example, a binomial expression. Something like x plus a. If I take x plus a whole power n, this n I will take as positive integer and it is called index or power or exponent. N is any positive integer. And you can call the power is n, index is n, or exponent is n. Suppose if I give you a binomial expression of this kind, x plus a, and then x plus a is taken power n. That means I can expand it. It is an expansion. I can expand it. Then I will be having many terms. So the formula for x plus a whole power n is, to remember this formula, I will tell you one easy method. Write NC0, NC1, NC2, NC3, like that it goes up to NCN. So these all are different terms. So they are separated by plus. Next, the first term x, it is raised to power n. Here n minus 1. To remember, you can, I will highlight. Here you will have n and 1. So n minus 1. Here n and 2. So x power will be n minus 2. Here n and here 3. So x power will be n minus 3. Here n and this is also n. So the power of x will be n minus n, that is 0. So remembering that, you can say here x power will be n minus 2, here x power will be n minus 3, here x power will be 0. X power 0 is nothing but 1, so I'm not writing it. Now, coming to the second term, that is a. We have another term a. Now, how to write that a? To write that a, we will remember this down one, 0. A power is 0. A power is 1. A power is 2. A power is 3. A power is n. In that way, we can remember. So a power 0 means it is 1. So I will not write anything in the first term. Second term, a power 1, then a square, then a cube. The last term will be a power n. So like this, if you follow this pattern, it will be easy to write this binomial expansion. This is called binomial expansion. And this formula is called binomial theorem. So I will highlight this formula like this. And this is based on a theorem, and that theorem is binomial theorem. So in this expansion, you can see there are many terms. How many terms are there? Because the power is n, I can say number of terms in this binomial expansion will be 1 extra. That is n plus 1. Similarly, if you want any term, like if you want to find first term, second term, third term, in the middle somewhere you want to find 100th term, or if you want to find 1000th term, or in general, if you want to find any term, tr plus 1, this is called general term. Any term tr plus 1, if you want to find, there is a formula, ncr x power n minus r a power r. Now this is again easy to remember, because what is the power for x? N minus r, as I told you. And then what is the power for a? It is r, the down one. In this way, you can remember the formula for any term in the binomial expansion. Now, let us go to the next example in which you will apply whatever you have learned. For example, I will give you a binomial expansion 2x square plus 1 by x whole power 12. And I want you to find 10th term. So do you remember what is the formula I told you? I told you general term formula. So that you have to apply here. The general term is tr plus 1 equal to ncr, x power will be n minus r, a power will be r. So in order to fill up in this formula, you must know each and every. First of all, I want to find 10th term. That means this r plus 1, I have to make it equal to 10. And so r I will get 9. So I will write put r equal to 9. Then next n. See the expansion 2x square plus 1 by x power 12. How this is looking like? X plus a power n. So I can equate n to 12. I can compare n with 12. So n is equal to 12. And now I want r. I know what is r. R is 9. Next, I want x. So x, I have to write it as 2x square. Compare and see. In place of x, I will write 2x square. Okay, I know n, I know r. Next is a. A, I have to compare with 1 by x. So a is 1 by x. And I know r. So now I will write each and every term here. In place of n, I will write 12. C, r is 9. In place of x, 2x square power. N is 12 minus r is 9. And then a is 1 by x power r is 9. So if you have to simplify this further, you will write 12c9 2x square power 3 and then 1 by x power 9. More if you want to simplify, 12c9 into 2 cube into x power 6 by x power 9. Further, 12c9 can be written as 12c3 because 12 minus 9 is 3. And then 2 cube is 8. Down, you have x power 9 minus 6. Now 12c3 is start with 12, take 3 numbers, divide by 3 factorial, that is 6. 6 ones, 6 twos. And then you have 8 by x cube. When you multiply all these numbers, you will get 1760 by x cube. This is how in this particular binomial expansion, we could find the 10th term. Now, there are different kinds of binomial expansions like 1 plus x whole power n. Now, I can use the same formula. What is the formula? Write NC0, NC1, NC2, NC3, and so on up to NCN. These all terms you will be adding. Then the first one is 1. So 1 power anything will be 1. I need not write. The second is x. So first term I will have x power 0. Next x power 1. Then x power 2. X cube. X power n. This is the binomial expansion as per binomial theorem. But there is a short way of writing, because in this chapter, everywhere the power will be n only in all the formulas. Usually you will have in all the formulas power n. So you can avoid writing NC0. You can just write C0. Instead of writing NC1, you can write C1x. Instead of writing NC2, C2x square. This is the short way to remember the formula. The last term will be Cn x power n. Now, suppose if you want to put x as 1 in this formula only, if x is 1, then you will have 2 power n equal to C0 plus C1 plus C2 plus C3, so on up to Cn. So this became another formula. So in the expansion 1 plus x whole power n, if you find the sum of coefficients, these all are called coefficients. C0, C1, C2, C3, Cn. These are called coefficients. If these coefficients, if you add, the answer will be 2 power n. So this became a formula. Now I know that C0 is 1, NC0 is 1. So 2 power n equal to 1 plus C1 plus C2 plus C3 up to Cn, or C1 plus C2 plus C3 up to Cn will be equal to 2 power n minus 1. This one you can take it to the other side. In this way, this became another formula. Now, in this formula, if I take odd numbers on one side, C1, C3, C5, like that, odd numbers. And if I take even numbers, C2, C4, C6, another side. So this will make half of this entire thing. Where is the entire thing? This entire thing, we are dividing it into two halves. C1, C3, C5. Or in other words, this entire thing, I will tell you in the next page, it will be more clear. So what I was saying is, we know that C0 plus C1 plus C2 plus C3 up to Cn, the formula is 2 power n. Now I will cut this entire thing into two halves. I will take even numbers C0, C2, C4 as one half, and C1 plus C3 plus C5, all odd numbers, as another half. I'm cutting it into two halves. That means 2 power n also I will cut into half. Half of 2 power n, half of 2 power n. That means this is 2 power n minus 1. This is also 2 power n minus 1. So I am getting a new formula. C0 plus C2 plus C4 and so on is 2 power n minus 1. Similarly, C1 plus C3 plus C5 so on is another 2 power n minus 1. These two also can be taken as the formula. Then coming to the next formula. If you take 1 minus x power n, what will be the binomial expansion? Again, I will use the method I told you. First C0, C1, C2, C3, so on up to Cn. Because here we have minus, alternate terms will be positive, alternate terms will be negative. C0 will be positive, C1 negative, C2 positive, C3 negative, and so on it will continue. Then when you come to 1 power anything will be 1 only. So we will start with x. X power 0 I need not write. X power 1, x power 2, x power 3, x power n. The last one, I don't know whether it is plus or minus. So I will write minus 1 power n. It depends what will be the last term. So now what did I write? 1 minus x whole power n is C0 minus C1x plus C2x square. Then next one will be minus C3x cube. Last one, I don't know what it will be. So I will write minus 1 power n Cn x power n. I don't know whether it will be plus or minus. Now in this, if I put x equal to 1, I will have 0 equal to C0 minus C1 plus C2 minus C3, so on, minus 1 power n Cn. So I got another formula for sum of coefficients. This is also sum of coefficients, but it is in the expansion 1 minus x whole power n. Now, if you have any binomial expansion x plus a whole power n, how are you going to know about the coefficients in various terms? How will you find the coefficients of various terms? For that, there is a triangle called Pascal's triangle. What is this Pascal's triangle? I'll write it on the next page. Suppose the power of binomial expansion, we will take different, like first power is 0, the power is 1, the power is 2, the power is 3, the power is 4, the power is 5. That means something like this: x plus a power 0, x plus a power 1, x plus a square, x plus a whole cube, x plus a whole power 4, x plus a whole power 5. This is what I mean. So you will have many terms, and in all terms there will be coefficients of terms. Each term will have coefficients. What are the coefficients? Suppose if it is x plus a whole power 0. Suppose if you have x plus a whole power 0, it is nothing but 1. So there is only one coefficient, that is 1. Next, suppose if it is x plus a whole power 1, there are two terms, x and a. Did you see the coefficient of x is 1, coefficient of a is 1. So we have two ones here, here and here. In this case, only one. In this case, two ones are there. Suppose if it is x plus a whole square. When you take x plus a whole square, you will have x square plus 2ax plus a square. See, the coefficient of first term is 1. Coefficient of the second term is 2. Coefficient of the third term is 1. So when you write the coefficients, coefficient of first term is 1, coefficient of second term is 2, coefficient of third term is 1. So what did you observe is always the ends 1, 1, 1. See here, 1, 1. The ends are remaining 1. Whereas in the middle, if you see, 1 plus 1 will give you 2. So the same process we can repeat for others also. So if I want to write coefficients of power 3, then end I will write 1. This end I will write 1. 1 plus 2 is 3. 2 plus 1 is 3. So first term, when you see the coefficients, first term's coefficient will be 1. Second term's coefficient is 3. Third term's coefficient is 3. Fourth term's coefficient will be 1. When you take expansion of x plus a whole cube. Similarly, when you take expansion of x plus a whole power 4, first will be 1, last will be 1. In the middle, 1 plus 3 is 4. Then 3 plus 3 is 6. 3 plus 1 is 4. These are the coefficients of 5 terms in the expansion of x plus a whole power 4. Similarly, in the expansion of x plus a whole power 5, the first coefficient will be 1, the last coefficient will be 1. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. These are the 6 coefficients of 6 terms in the expansion of x plus a whole power 5. This is only called Pascal's triangle. As much as possible, you can expand this triangle and find the coefficients of the terms in the binomial expansion. Now, in the binomial expansion x plus a whole power n, the power n can be even, the power n can be odd integer, odd positive integer, even positive integer. Then I have to find middle term in the expansion. What is the method to find middle term? When n is even, the middle term will be which term? N by 2 plus 1th term. But when n is odd, there are two middle terms. What are the two? One is n plus 1 by 2th term, and the other one is n plus 1 by 2th plus 1th term. These two will be the middle terms. But for this, you have to by heart. Without by hearting, without learning, you won't get anything. All are not that easy. So, if you do one example on that, it will be easy to remember the formulas and easy to understand the formula or problem. For example, I am giving you a binomial expansion 2 by 3 x square minus 3 by 2x whole power 20. You have to find middle term in this expansion. They are asking you to find middle term. First of all, the power n, it is 20 and it is easily even. So I gave you one formula for middle term. When n is even, what is the formula? N by 2 plus 1th term. So this I have to take. That means I have to take, because n is 20 by 2 plus 1th term. That means 10 plus 1th term. That is 11th term is the middle term. Now, how will I find the 11th term? To find the 11th term, TR plus 1 equal to NCR x power n minus R a power R. This formula I have to use. Okay, so I am finding 11th term. That means R is 10. N is already I know 20. Then in place of x, I will write 2x square by 3. Then in place of a, I will write minus 3 by 2x. All these I will write. So 20 C 10, 2x square by 3 power n minus r, 20 minus 10. Then a power r, that is 10. That means I have to expand or simplify this. 20 C10, 2x square by 3 power 10 minus 3 by 2x power 10. So if I simplify further, 20 C10, 2 will have power 10, x will have power 20, 3 will have power 10, minus power 10 will be plus only. 3 will have power 10, 2 will have power 10, x will have power 10. So 2 power 10 will cancel, 3 power 10 will cancel. Left is 20c10 x power 20 minus 10. That is 20c10 x power 10. This will be the middle term in this expansion. We will do one more example. It will be more easy for you. I am giving you the expansion 3x minus x cube by 6 whole power 7. I am asking you to find middle term again. But what is the difference here is the power n is 7. That means it is odd number. And when you have odd number, what is the formula to find middle term? There will be two middle terms. One is n plus 1 by 2th term, and the other one is n plus 1 by 2 plus 1th term. Two terms will be there. So I will put n as 7. So 7 plus 1, 8 by 2, 4th term, and 1 extra, 5th term. These two I have to find. So how will I find this? TR plus 1 equal to, I will write a little bit down. Okay. So how will I find this? I will take TR plus 1 equal to NCR x power n minus r a power r. So in this I have to find 4th term and 5th term. Both I have to find. So when I find 4th term, r will be 3. When I find 5th term, r will be 4. Then in both n is 7. Here also 7, here also 7. In both x is 3x. Here also in place of x, 3x. In both a is minus x cube by 6. Here also a is minus x cube by 6. So just I have to put it. 7c3. 3x power 7 minus 3. Minus x cube by 6 power 3. Here 7c4. 3x power 7 minus 4 minus x cube by 6 power 4. Once you concentrate, once you learn along with me, it will be very, very easy. So what I have? 7c3. How will I write 7c3? Start with 7. Take 3 numbers 7, 6, 5 by 3 factorial. 6 and 6 will cancel. 3 power 4, x power 4. Minus power 3 will be minus, so minus will come out. Then x power 9, down 6 cube. So when I take all the numbers and multiply, like I have 35, then 3 power 4 is 81 by down 6 cube. What is 6 cube? 216 into x power 13 I will have. So now I can cancel. How will I cancel? Suppose if I cancel with 9. So 9 nines 81. 9 twos 18, 9 fours. Now I will cancel with 3. 3 threes, 3 eights. So finally what I have? Minus 105 x power 13 by 8. So this is middle term. Another middle term also I can find. 7c4 is same as 7c3. What did you get for 7C3 here? You got 35. So same 35. Then I have 3 cube x cube. Minus power 4 will become plus. X power 12 by 6 power 4. Now 35. Next is 3 cube. 3 cube is 27. Down 6 power 4. What is 6 power 4? Instead of writing 6 power 4, I will write 36 into 36. It will be easy for cancelling. And then x power 15 I have. So 9 threes, 9 fours. Then 3 ones, 3 twelves. So I have 35 by 48 x power 15. This is another middle term in this given expansion. So we have got two middle terms here. Now I think you are very much perfect with this. You have to practice more and more problems. Okay. Suppose if you take binomial expansion x plus a whole power n. In this expansion, we have many coefficients of n plus 1 terms. What are the coefficients? C0, C1, C2, C3 up to Cn. These are coefficients. And somewhere in the middle, you will have CR also. Many like this you have. But out of all these, one particular coefficient has greatest value. Greatest coefficient. There will be a greatest coefficient. Which one will be the greatest coefficient? I don't know. It can be C0, it can be C1, C2, CR, Cn. So let us take CR is the greatest coefficient. Now, how to find CR? Whether it is greatest coefficient or not, how to find? It depends upon the power n. If the power n is even, what is the greatest coefficient? If the power n is odd, what is the greatest coefficient? We are going to find a formula for this. Now, when the power is even, of course, NCR will be the greatest coefficient. But in place of R, you have to write n by 2. Then it will become the greatest coefficient. When the power n is odd, then also NCR is the greatest coefficient, I agree. But in place of R, you have to put n minus 1 by 2 or n plus 1 by 2. Because when n is odd, you will have two greatest coefficients. Both will be same. Either you can put this or this. Both will be same in place of R. That means what I want to tell you is when n is even, NCn by 2 is the greatest coefficient. When n is odd, NC n minus 1 by 2 or NC n plus 1 by 2. These are the formulas to find greatest coefficients in binomial expansion. Similarly, like greatest coefficient, in a binomial expansion, you can find greatest term also. There is a method to find greatest term. What is the method is, first of all, you have to find value of something. What is that something? I will tell you. You will take n plus 1 by x by a plus 1. This is what you will take. And you will find what is the answer. Suppose the answer is P. P is an integer. If the answer is P, then what will be the greatest term? There will be two greatest terms. We will have two greatest terms. What are the two greatest terms? One is pth term and the other is p plus 1th term, but both will be same. Both will be equal only. Okay, but if this does not happen, when you find n plus 1 by x by a plus 1, it is not integer. The answer is not an integer. Suppose you will get not an integer means something like m.5, m.6, m.7, some number. I'm not writing. You will get some decimal number, m point. Okay. So this m is called integral part. Integral part. And whatever the decimal is there, after point, whatever is there, that is called decimal part. So suppose if you get m as the answer, then there will be only one greatest term in the expansion, and that is m plus 1th term. So you can find greatest coefficient. You can find greatest term also, remembering this formula. Okay, so now suppose, as you know how to find the greatest term now. Suppose if I give you x plus y whole power n, and if I ask you to find greatest term. In the previous one, I told you for x plus a whole power n. That means x is variable, a is number. But now I am taking both x and y as variables. In such case, how to find greatest term? So first of all, I will take x power n common. Then I will have 1 plus y by x whole power n. Then I can find the greatest term easily. How to find greatest term here? For that, I have to tell you one more formula. After that formula, we will come to this. Suppose if I give you 1 plus x whole power n, and if I ask you what is the greatest term, how to find the greatest term. Again, I will give you one formula. You have to find the value. Value of what? Like I told you in the previous paper, you have to find the value of absolute value of x into n plus 1 by x plus 1, which will be some m. Suppose if m is integer, if answer you will get as integer, then the greatest term will be tm as well as tm plus 1. Mth term, m plus 1th term, both will be same if m is integer. Suppose m is some, like if the answer you will get m point something, some decimal number you will get. So you will take m as the integral part, whereas here you will have decimal part. Like this you will have. Then in such case, what will be the greatest term? The greatest term will be, as you have discussed here, In the previous one, what did you discuss for the greatest term? M is the integral part. The same way, what you will do is M plus 1th term will be the greatest term. So this formula will be helpful in the case I told you. Like if I give you x plus y whole power n, and if I ask you greatest term, this is difficult because, why this is difficult? Because there are two variables. Both x and y are variables. That is why this is slightly difficult. Greatest term you have to find. So first of all, you will take x power n common. You will have 1 plus y by x whole power n. So separately, you will take this expansion 1 plus y by x whole power n. You will find the greatest term as I did in the previous page. And that you will multiply with x power n, because x power n is outside, to get the result. We will do some examples, then it will be easy for you. I will give you 2 plus 3x whole power 9. And I will give you x is equal to 3 by 2. And my question is, find the greatest term of this expansion. This is my question. So what I can do is, I need not do, but to make it easy, what I will do is I will take 2 power 9 common. Then I will have 1 plus 3x by 2 whole power 9. This will be easy for me. That is why I am doing here. Now, because I know x equal to 3 by 2, in this I will put x equal to 3 by 2. So what I will have? 9 by 4 whole power 9. Okay, so now I have to find value. Value of what? Absolute value of x into n plus 1 by x plus 1. I have to find. So what I will do? Absolute value of, what is my x here? See, compare with the formula. What is the formula? 1 plus x whole power n. Because I'm finding greatest term of only this part. Later on, I will multiply 2 power 9. So, I have to take x. Compare and take x. So, in place of x, I will write 9 by 4. The power n is 9 plus 1. X is again 9 by 4 plus 1. So, this will give me 9 by 4 into 10. 90 by 4 by 9 plus 4, 13 by 4. This 4 and 4 will cancel. I will have 90 by 13. This 19 by 13, when I divide, I will get 6 point something. 612 by 13. So I will see only the integral part. I will not see the decimal part. Decimal part is not important for you, because the integral part is 6. What will be the greatest term? I have to find the greatest term. It is m. So 6th term plus 1. Because I have to take tm plus 1. Do you remember? Tm plus 1, 6 plus 1. That means 7th term will be the greatest term. Now, how to find the 7th term? The formula. But remember, not only 7th term, you have to multiply with 2 power 9 also. So in order to find greatest term, I will multiply 2 power 9. I will multiply 2 power 9. So 2 power 9 into 7th term. N, C, R. What is my X? X power N minus R. 1 power anything will be 1 only. Then what? My X is 9 by 4 power 6. Isn't it? This is what I have to find. So when I simplify, I will have 2 power 9. 9C 6 is 9C3. Start with 9, 8, 7. 3 numbers by 3 factorial. And after that, what I will do? 9 power 6 by 4 power 6. These all numbers I have to multiply. It is very difficult to multiply all these. So I will try to put it in easy way. How? 3 2s, 3 3s. I will write 2 power 9 and then all 2s I'm taking on one side into 3. 8 is 2 cube, then 7. 9 is 3 square, so 3 power 12. Down what I have? 2. And 4 is 2 square, power 6, so 12. That means in the numerator, I have 2 power 12 and 3 power 13 and 7. Denominator, I have 2 power 12 and 2. So 2 power 12 I can cancel. And then in short, I can write 7 by 2 into 2 power 13. Or, sorry, a small mistake. So I can write 7 by 2 into 3 power 13. This will be the greatest term. So see, it will be difficult in the beginning, but you have to practice lots and lots of problems. It will be easy for you. Okay, so now I will give you one more formula. In the expansion 1 plus x whole power n, I will give you formula for greatest coefficient also. That happens in two cases. If the power n is even and if the power n is odd. If the power n is even, greatest coefficient will be nc n by 2. If the power n is odd, greatest coefficient will be nc n minus 1 by 2 or nc n plus 1 by 2. It is same. We need not put any effort to by heart this formula. Okay. Now, some problems in some type of questions, you will be asked different like unimaginable, or you can't even expect that kind of questions. For example, I will give you x plus a whole power n binomial expansion. I will ask you m plus 1th term, but not from the beginning. From the end, I will ask you, from the last. Then for that, there is a formula, and that is n minus m plus 1th term from beginning. If you want from end, this is the formula to be used from the beginning. Same way, many more questions will be asked. As per that, you have to apply. For example, in expansion x plus a whole power n, they will ask you coefficient of x power m. If they ask you what is coefficient of x power m, what will you do? What is the procedure? You will take general term, NCR, x power n minus r, a power r. They are asking x power m, but you have n minus r. So n minus r, you will equate to m. In that process, r you will get as n minus m. So that you have to put it in general term. In place of r, you will put n minus m plus 1. In place of r, you will put n minus m. In place of r, you will put n minus m. A power in place of r n minus m. So what you will get is n minus m plus 1th term, and that will be nc n minus m, a power n minus m, and x power m. In this way, this will be the coefficient. Whatever I have circled, that will be the coefficient of x power m. This is, I'm telling you in general, the procedure. You will understand better if you take some example and do it. Okay. In the beginning, I told you, whenever you take binomial expansion 1 plus x whole power n, beginning itself I told you, n is a positive integer, and we did all the formulas, all the problems with this case. But from now onwards, we will have 1 plus x whole power n expansion, where n is any rational number. Remember, n we can take any rational number. And one more thing we have to take, absolute value of x should be less than 1. Then we have a formula for this expansion also, which is 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 by 3 factorial x cube, so on, but it will go to infinity. It will never end. This is also called as binomial theorem. But for any power, any index, not only positive integer, it is for any power, any index. Now, we will learn a few things here. If you take 1 plus x whole power n, first term is 1 here. Whatever I wrote, I'm writing the same. Second term is plus nx. But because the remaining terms are very small, x square will be small, x cube will be small, so they all can be neglected. X square, x cube, x power 4 are very small numbers, and so you can neglect them. You can just write the first two terms only. These first two terms only you can write and neglect the remaining. But this is only when the power n is any index. Next, apart from this, we have some more formulas which I'm going to write now. I think before the formulas, I want to tell you one thing. If you have x plus a whole power n, in some questions, they will ask you, find the term independent of x. That means x should not be there. That means nothing but coefficient of x power 0. X should not be there means x power 0 will become 1. There will be no x. This is what you have to find. So what you will do? You will take TR plus 1, NCR, x power n minus r, a power r. X power n minus r should be 0. N minus r should be 0. That means r should be n. So write everywhere r as n. Write r as n. Write r as n. Here also write r as n. That means NCN is 1, a power n, x power 0. That is a power n into x power 0. So this is a power n is coefficient of x power 0. That means Tn plus 1 is the term independent. There will be no x at all independent of x. Now I can tell you some formulas for which there is no explanation, just you have to by heart. The first one is C0 square plus C1 square plus C2 square, so on up to Cn square is 2n factorial by n factorial square. The second formula is C0 into C1 plus C1 into C2, so on, plus Cn minus 1 into Cn will be equal to 2n Cn minus 1, or it will be equal to 2n factorial by n minus 1 factorial into n plus 1 factorial. Similarly, the third formula is C0 into CR plus C1 into CR plus 1, so on, Cn minus R into Cn. It will be equal to 2n Cn minus R. That means it will be equal to 2n factorial by n minus R factorial into n plus R factorial. After that, we have some more formulas, multinomial theorems and all that we will learn in the next class. So today we are going to stop here, learn all these, practice more, come prepared for the next class. See you in the next class.